Hi guys, welcome to In 5 Minutes. We are currently dealing with memory management, and the next topic in memory management is memory allocation. Now, what exactly memory allocation is about and what are we talking about? We all know some basic thing about RAM, that is the memory which we are talking about, that from the secondary storage it would be brought to RAM, and from RAM it will go to the CPU. What we mean by this? Let's see this. We all know that we have a hard disk drive, which is a storage. Technical name HDD, hard disk drive. Data would be coming from this particular part to something which we call as RAM. This is RAM, and from RAM it will ultimately reach to the CPU. So what we are talking about this way was a concept that data from the storage would travel to RAM, and from RAM at some location where it will be stored, it would be transferred to the CPU. The overall concept is fairly simple. Data from storage to RAM gets stored at some location in RAM and then read by the CPU and brought to CPU itself. Now there is a concept of allocation in this. What do you mean by allocation? Okay, the allocation process simply refers to the fact that given any time, given any moment of time, RAM will not consist a single process. Why? Today we are dealing with OS which are multitasking by nature. If we are dealing with OS with multitasking nature, the first thing we'll always come across is the RAM, which consists multiple processes, each one involved in the multitasking. Consider this. This is a typical RAM representation which I am showing. This is the OS area, and this particular part can be understood as the user area. As I was saying earlier, at any given moment of time, RAM would consist multiple processes. Each ith process may require k bytes in RAM. So what exactly allocation is about? Allocation is about one simple factor is whenever a particular process is needed, that particular process, let's say process X, would be brought to RAM at some location, and then when given a chance would be executed, process X. Now when we are dealing with this kind of a phenomena, if it is a traditional system, entire user area can only keep one process. But now problem with this factor would be, consider this, I want process X, process Y, process Z. Under normal circumstances, anyone can be in and remaining would be waiting. Consider in this example, I would give process X, which is currently in the RAM and getting executed. But this process X might take only some part of the RAM. Remaining part is free. In current example, I am considering OS will only have two parts, or rather RAM used by the OS will only have two parts. One area in which OS is residing, second is user area. But we soon understand from the example that even after giving process X space in the RAM, good amount of area is free, which can be given to some another process. That's the reason in memory allocation, more important factor is who, how, and how we will work. So let's go with it.